All right, guys, so before we get started on today's lesson, are there any questions over any of the assignments thus far? Any questions over any of the assignments thus far? Okay. So the first thing we're looking at today is, well, fundamental theorem of algebra. Now, when we look at these three equations, the first one, 2x minus 1 equals 0. Well, the degree is 1 because the biggest exponent we have attached to the variable is 1. And if we worked it out, the solution is 1/2, and we have a total of one solution. Now, the next equation we have on this chart is x squared. So the degree is 2 because the biggest exponent is 2. Our solutions that we have are plus or minus the square root of 2. So we have a total of 2 solutions. The next one, x cubed minus 8 equals 0. So the degree is 3 because the biggest exponent is 3. And it works out our solutions are 2, negative 1, plus or minus I squared of 3, which is a total of 3. And the last one, the degree is 3. Our solutions are negative 1, and 1. And again, we have 3 solutions. Now what this leads to is the fundamental theorem of algebra. So if a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0, where it's equal to 0, has at least one solution in the set of complex numbers. Now, so if x equals 5, we can make this a complex number by adding 0i to it. Because complex numbers comes in the form of a plus bi. So really, we can make any number a complex number by adding 0i to it. Now, the more important thing comes from the corollary. What comes from the theorem itself. If a polynomial of degree n, where n is greater than 0, then the function f of x equals 0 has exactly n solutions, where our degree is n. Provided each solution repeated twice is counted twice. Each solution repeated 3 times is counted 3 times, and so on and so forth. So, if we look at this one here, how many solutions does this equation have? Because the degree is 3 solutions. It works out that the solutions are negative 3, 4i, and negative 4i if we wanted to work them out. But the main thing is that it has 3 solutions. How many zeros does this function have? It would be 4. And it works out that if we found them, it would be negative 2, and 0. How many solutions does it have? Because the degree is. How many solutions does this one have? Because the degree is. And this one here. Be careful, especially on the homework, because they might not put it in standard form. Because they can sometimes hide a variable with a bigger exponent somewhere further in. So this is the next one we're going to look at. So how many solutions should we have for this function here? 5, because the degree is 5, yes? Now the first place I would start in actually finding these zeros is to graph this function. So we can clear this out. Clear. So we say y equals. So we can say x, how many zeros? 0. Here we go. X to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. We hit graph. So for this function here, we know we have 5 solutions. So it would be nice if we did get 5 numbers that worked. But we got how many here? Because we know 2 for sure, yes? And we talked about when it intersected the x-axis but didn't cross it, it might have an even multiplicity. So the 0 might show up more than once there. So if we look at the table, our two zeros are at -1 and 2. And there's a chance, if we look at the graph, that -1 could show up more than once because it intersected the graph x-axis but didn't cross it. So what we can do is come back over here and do synthetic division. Now the numbers going across the top, we'll have 1 for x to the 5th, and then our next number would be, because we don't have an x to the 4th, then we would have 1 for x to the 3rd, -2, -12, and -8. Which number do we want to use first? It really doesn't matter. We can do 2 or -1, either one. We just need to pick one and use synthetic division with it. So 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. 10 plus -2 is 2 times 8 is 16. -12 plus 16 is 4. And lastly, 2 times 4 is 8. And -8 plus 8 is 0. Yes? Let's do this again. But this time, instead of with 2, we're going to use it what? Is it 1 or -1? -1. So -1 times 1 is -1. 2 plus -1 is 1. -1 times 1 is -1. 5 plus -1 is 4. -1 times 4 is -4. 8 plus -4 is 4. And -1 times 4 is -4. Now again, we said it looked like at -1 it intersected the graph but did not cross it. So we could try -1 again to see if it works again. If it doesn't, then we'll have to try to factor from here. Well, -1 times 1 is -1. 1 plus -1 is 0. -1 times 0 is 0. 0 plus 4 is 4. And lastly, -1 times 4 is, which gives us a 0. Now we have a quadratic because we've done synthetic division 3 times, taking the degree from 5 down to 2. So if we put the variables back in, we have our remainder. We have 4 is our term without x, 0 is our term with x, and 1 is our term with x squared. So what we're left with is x squared plus 4 is equal to 0. Do we have a middle term? No, so we can use the square root method. So the first thing we can do in the square root method is to subtract 4 from both sides. Well, these will cancel out, telling us x squared is equal to -4. What can we do next? Square root both sides. Square root of x squared is x is equal to plus or minus. The negative is going to come out as, and the square root of 4 is 2. So we have plus or minus 2i. We also have what? -1, -1, and 2. Because we have 5 solutions. Questions on this here? Now we don't write it in, but really here we have plus 0x, yes? So if we wanted to do this by the quadratic formula, we could. all over 2a. Well, the value of b in this case is 0. A is 1 and c is 4. So really we have 0 plus or minus all over 2. Well, in the calculator, we can do 0 squared minus 4 times 1 times 4, which tells us it's negative 16. So here we have negative 16. But the 0 up front really isn't adding anything or subtracting anything from it, so we just have plus or minus. Well, the negative is going to come out as I square root of 16 is, and 4 divided by 2 is. Same thing we got going the other way. Both work. Square root method's a little bit easier than that. Any questions on this here? Let's look at the next one. X cubed plus 7x squared plus 16x plus 12. So the first thing we can do is graph it. And we know how many solutions should we get for this function? 3. If we get 3 solutions, we know we are finished. We'll have all of them. But at most we should have 3. The least we want is what? 1. Because if we can get at least 1, we can take it down to a quadratic and we solve from there. But here we're given 2, yes? Because we do know negative 3 and negative 2 work. One of those could be repeated, could be a repeated solution. But we know that the other solution is not going to be irrational because it doesn't cross anywhere else that we can see. And it's not going to be complex. Because imaginary solutions with I always come in pairs. We always have a positive and negative case with I, yes? So we would need 2, but we only have how many left? So it can't be complex. Does that make sense? Or imaginary? Well, you can set this up and do negative 2 first. So we have 1 for x to the third, 7 for x squared, 16x for x, and 12. Well, negative 2 times 1 is 7 plus negative 2 is. Negative 2 times 5 is. Negative 10 plus 16 is 6. Negative 2 times 6 is negative 12, which gives us 0. Now at this point here, we could put the variables back in and use the quadratic formula to solve. But do we know one of the other solutions? Negative 3. If we can take it from a quadratic down to a linear, we might as well, because linear functions are easier to solve than quadratics. Now negative 3 times 1 is negative 3. 5 plus negative 3 is. Negative 3 times 2 is, which is 0. Remainder, term without x, term with. So we have x plus 2 is 0, yes? And we also have that negative 2 and. So if we can get it down to a linear function, that's even better. I mean, we could have seen that negative 2, it does not cross the graph, it intersects it, that's fine. But this works just as well. Any questions on any of these here? We have one more that we're going to look at with this and using this. So if we have this here, x to the 5th minus 3x to the 4th plus 5x cubed minus x squared minus 6x plus 4. So we know for sure we're going to have how many solutions? 5. And if we can graph it and get 5, that's great because then we have every single solution. But how many do I want at least? 3, because if I have 3, I can take it from a degree 5 down to a degree 2, and we can solve from there. If I have 4 solutions that work out nicely, that's even better. And 5 would be the best case scenario. So when we graph this here, we do see that it crosses at -1, and it hits at 1. It's hard to tell if it crosses or not, but it looks like, yep, at -1 and 1 we have 0. Because it doesn't look like it crosses at 1, there's a chance that there could be an even number of zeros there. So we can do -1 first, and then across the top we'd have 1, -3, 5, -1, -6, and 4. And we can do our synthetic division again. -1 times 1 is -1. -3 plus -1 is -4. -1 times -4 is 4. 5 plus 4 is 9. -1 times 9 is -9. -1 plus -9 is -10. -1 times -10 is 10. -6 plus 10 is 4. And -1 times 4 is -4. And 4 plus -4 is 0. The next number we had was also 1. So we had 1 and -1. So we do this again with 1. Well, 1 times 1 is 1. -4 plus 1 is -3. 1 times -3 is -3. 9 plus -3 is 6. 1 times 6 is 6. -10 plus 6 is, and 1 times -4 is because it looked like it crossed twice or didn't cross at 1, we can try 1 again to see if it works. Well, 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 6 plus -2 is 4. 1 times 4 is, which gives us 0. Now, for the previous one, with this here, well, the equation we actually have is x to the third minus 3x squared plus 6x minus 4. You don't have to write this down. But this is what it would be, yes? Now, the normal function doesn't tell us exactly if 1 is repeated twice. 1, -3, 6, -4. X to the third minus 3x squared plus 6x minus 4. Well, we do see that it crosses, and this function does cross at 1. So we could put the new equation in and see, does it cross at 1 still? And it does. And so that kind of verified it. Now, what we have left, remainder, term without x, term with x, term with x squared. This is the function that we have left. Now at this point here, we could try factoring, we could try graphing, we could do completing the square or the quadratic formula. At this point here, it's going to probably be a little bit easier, just use the quadratic formula, solve, and see where we get. Now the first thing we have is negative b. Well, a is the number in front of x squared, b, and c, yes? So we have negative b, or negative -2, yes? Negative -2 is the same as what? Is positive 2. The denominator is 2 times a. Well, a in this case is 2 times 1 is 2. And those two I will do on the first step. Because a negative is a positive. If it's b is positive, it's just the negative version of it. Even if a is not 1, if a was like 3, well, still 2 times 3 is 6. Those aren't bad. I will still write this back out every time. I will still put that in there as that there. Now, our first part, b squared, negative 2 squared, is always going to be what? Positive, yes? So in the calculator, we can do this one of two ways. Because I can go parentheses, negative 2, close parentheses squared, minus 4 times 1 times 4. Hit enter. And we get negative 12. What we could have done is said 2 squared minus 4 times 1 times 4 is if I know that the b squared is going to be a positive number, I can just put a positive version of that number and square it. Does that make sense? So that's something I will do because I know the number is positive. I'll just end up being positive, so I don't put in parentheses negative 2, close parentheses squared. I just put the positive number squared. But if you're unsure on that, go and put the parentheses around it and keep the number the same. So what that tells us inside the square root is negative 12. Now the negative with the square root of 12 is going to come out as I, yes? Which leaves us with the square root of 12. Now the graphing calculator probably is not going to help us unless it is a perfect square. But the calculator will tell us that this is 2 square root of 3. So the square root of negative 12 is 2i square root of 3. Questions on this here? Makes sense? Yeah. So again, with these negative radicals, I always take it part by part. Now, will both of these divide by 2? Yeah. Now, one way we can think of this is that really we can split this up into 2 fractions. The numerator for the first is 2. The numerator for the second is 2i squared root of 3. And they're both over 2. Well, the first one, 2 divided by 2 is, here 2 divided by 2 is, which just leaves us with I square root of 3. But we also have 1, 1, and negative 1. And that's it. Questions on this here? And that's all we have to do for these here. We good with these here? Complex conjugate theorem. This is kind of like the irrational conjugate theorem that we had yesterday, or Friday, not yesterday, which is pretty much saying if A plus BI is a solution, then A minus BI is a solution. And we more or less have already had this. I already talked about this. But we're mainly going to use it in the form that we did Friday. We're going to find the polynomial that has zeros of 2 and 3 plus I. So all this is saying is that x is equal to 2 and x is equal to 3 plus I. Well, if that's the case, it also means x is equal to 3 minus I. Questions on this so far? Way is that we're going to move everything over and get them equal to 0. So here, add minus 2 from both sides. Get this here. Next one, we would minus 3 from both sides. And we would minus I. We get this here. Now, this last one's just the conjugate of the one we just did, yes? So the only thing that's different is that I is in here. Yep, so it's just going to be plus I. Because the one before was positive I on the right side, negative, so the signs are just going to change. And if we did this step by step, minusing 3, it's the same thing. Or we can do the little shortcut I showed you just a minute ago. Both work. One's way faster than the other. Because that's all we're doing. We're just really using the opposite sign to move it over. Now the next thing we need to do is multiply them together. And again, what we want to multiply first is always the conjugates. We want to multiply the conjugates together first, because if we multiply the conjugates together first, it's going to make it easier to work with. So here, we're going to distribute the x. X times x is x squared. X times negative 3 is negative 3x, and x times negative I is negative xi. I'll change color just to make it a little bit easier to see. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times negative I is plus 3i. And last but not least, we got to distribute the I. Negative I times x is negative xi. Negative I times negative 3 is plus. Let's see here, make sure. Nope. This should be plus. Miswrote that. So this here would be plus, and the 3i would be negative, yes. Now the reason I knew that there was an error was because, again, all the I terms should cancel out, yes? And I just noticed, because we have 3i, our new one is plus 3i, because negative I times negative 3 would be plus, yes? The other time that we had 3i, it was also plus to begin with, yes? Positive 3i plus 3i is not going to be 0, so there's probably something wrong. Xi, negative xi, those work. And then lastly, negative I times positive I is going to be negative I squared. Because when we multiply the conjugates, either irrational or complex, in the irrational case, all the radicals should cancel out. In the complex case, all the I terms should cancel out. So when we look at this here, positive xi minus xi, that is indeed 0. Negative 3i plus 3i, that is 0. And the last one we have is negative I squared. Now what is I squared? Negative 1. I squared is negative 1. But what we have is negative I squared, which is really saying we have negative 1, which is plus 1, positive 1, yes? So what we can do is come in here and say, mark it out and say plus 1. Well, we have x squared. Negative 3x minus 3x is negative 6x. 9 plus 1 is plus 10. And last but not least, we need to distribute. X times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 10 is plus 10x. Then we do the same thing with negative 2. Negative 2 times x squared is negative 2x. Negative 2 times negative 6x is 12x. And lastly, negative 2 times 10 is negative 20. And again, I do this kind of tier step most of the time, just so that I line the like terms up. It's easier to work with. X cubed does not have any like terms. Negative x squared minus 2x squared is negative 8x squared. 10x plus 12x is plus 22x, and then we have minus 20. Any questions on this here? Any question over anything we've done so far today? Be good with this here? All right.